All right, next, case number 2, simplifying the expression. So if we have the cosine of x minus pi, we can use the cosine formula and say cosine of x, cosine of pi. Remember, it's the opposite sign, so we'll do a plus sine of x times sine of pi. Well, the cosine of pi equals -1, so this is cosine of x times -1. The sine of pi equals 0. So we will just end up with negative cosine of x. All right, so the sine formula we can use to simplify this one. So we'll do the sine of theta times the cosine of pi over 2 plus the sine of pi over 2 times the cosine of theta. So then we evaluate cosine of pi over 2, that's 0. The sine of pi over 2 is 1. And so we're just left with cosine of theta. All right, case number 3, simplifying into a single expression. So we're going to use the sum or difference identities for sine or cosine to write each of the following as a single sine, cosine, or tangent expression. So what I notice is we've got the sines together and the cosines together. So if we go look at our formulas, that's cosine. And whatever sine's in the middle, we need the opposite of it over here. So it's a plus sign, so we'll need a minus sign. So this would be equivalent to the cosine of 5x minus 2x. And so we'll get the cosine of 3x. All right, so letter B, since we have the 3 there, we need to factor that out. That's a GCF we can take to the outside because that's not a part of our sum or difference formula. So we'll just divide that 3 out to the front. And now if I look at what I have left in here, we've got the sine of x, cosine of 4x, cosine of x, sine of 4x, which means this is the sine sum. And because that's a plus, we know it's a sum. So it'll be 3 times the sine of x plus 4x, which would be 5x. So it's 3 times the sine of 5x. All right, so letter C, again, we've got sine and cosine and then cosine and sine. So this would be the sine sum and difference formula. So it's the sine of 14 degrees plus 16 degrees. So that's the sine of 30 degrees. And that's one of our special angles. So we can evaluate that. Remember, with our special right triangles, this is the 1, 2, square root of 3, and 30 degrees is the smaller angle, so it's across from the 1. So this is 30 degrees, so the sine of that opposite over hypotenuse. So our answer here is really just 1/2. All right, so we can see this one's our tangent sum or difference formula. And so because we have that minus sign in the top, it tells us it was a minus sign here. The sign of the numerator matches the sign of the original problem. So we will have the tangent of 20 degrees minus 5 degrees. So that's the tangent of 15 degrees. And we can type that into our calculator to see what that approximately equals. We do need to make sure we're in degrees since that's degrees. So I gotta switch mine over to degrees. So I went to mode, switch it out to degrees, and now I can say tangent 15 degrees and see that it's approximately 0.28. Or if we keep 3 decimal places, 0.268. All right, case number 4 here, using the 4-step process to find an exact value. So here's our 4-step process. Get rid of this for now. So step number 1, we're going to write the formula. Step number 2, we're going to draw the diagram. Visual always helps. Step number 3, we're going to substitute into the formula. And then we will simplify in step number 4. So number 8 says, if alpha and beta are measures of two first quadrant angles, find the exact value of cosine of alpha plus cosine of beta. Okay, so they're both in the first quadrant. So if I draw this here for alpha, sine is opposite over hypotenuse. So this is a 5, 12, 13 right triangle. You can do Pythagorean theorem if you don't know those Pythagorean triples. And here's beta. Cosine is adjacent over hypotenuse, so this is a 3, 4, 5 right triangle. So cosine of alpha plus beta, we've got cosine of alpha, cosine of beta. Remember our formula, we got to do the opposite sign. So because it's a plus, I'm supposed to do a minus sign here. And then sine of alpha, sine of beta. Okay, so that was step 1. I wrote my formula. Step 2, I kind of jumped ahead and did. There's my diagram. So now we're going to substitute in. So the cosine of alpha, here's alpha. Cosine would be 12 over 13. And then cosine of beta, they gave us here in the problem. So times 4/5. Sine of alpha, they gave us in the problem. So we've got 5/13. And then sine of beta, opposite over hypotenuse, so sine of beta, opposite over hypotenuse, so 3/5. All right, and now we simplify. So we get 48 over 65 minus 15 over 65. And so if we subtract, we get 33 over 65. All right, so number 1, let's write the formula. So it'll be sine of alpha cosine of beta plus sine of beta cosine of alpha. And number 2, I'm going to draw my diagrams. So they're telling me it's between 180 and 270, which means I'm in quadrant 3. So here's alpha, and they're telling me the sine is negative 3/5. So again, this is a 3, 4, 5 right triangle. So then that would be negative 4 since we're in quadrant 3. Both x and y are negative. This other one they're telling me is in quadrant 2, so it's between 90 and 180. And they said that the sine of beta, so here's beta, is 1 over 5. So if I do Pythagorean theorem, hypotenuse squared minus the leg squared would equal that other side squared. So 24 equals a squared, and so we're going to get 2 square root of 6 when we simplify the square root of 24 down. And that would be negative since we're in quadrant 2. So now we can plug into our formula. So the sine of alpha they gave us was negative 3/5. Cosine of beta, so if we come over here to beta, cosine is negative 2 square root of 6 over 5. Plus the sine of beta they gave us in the problem, that's 1/5, times the cosine of alpha would be negative 4 over 5. So really using our reference triangles here to find these values. And now we simplify. So we'll have 6 times the square root of 6 over 25 minus 4 over 5. 25. Almost forgot to multiply those denominators. And so we can put it together as a single fraction and say 6 times the square root of 6 minus 4 all over 25. All right, one more example here. So number 10, we've got cosine of alpha plus beta. So it will be cosine of alpha times the cosine of beta minus, since they're wanting the sum, and cosine's formula does the opposite. So minus sine of alpha times sine of beta. And so then I need my diagram. So both angles are in the third quadrant. All right, so we're over here. So the first one, so for alpha, they tell me the sine is negative 1/3. So if I do Pythagorean theorem, 9 minus the 1 will give me 8, and that would be the side squared. So if we simplify that down, we'll get 2 times the square root of 2, and it's negative since we're there in quadrant 3. And so if we do this one, so beta cosine is negative 1/4, so 16 minus the 1 would give us 15. So this will be the square root of 15. Again, I'm just using Pythagorean theorem and then simplifying my radicals there. So now we can plug in, so the cosine of alpha, here's alpha, cosine's negative 2 square root of 2/3. And then cosine of beta, they gave us in the problem, was negative 1/4. Sine of alpha, they told us was negative 1/3. And if we find the sine of beta, it's square root of 15/4. And so now we simplify. So we get 2 times the square root of 2/12 plus the square root of 15/12. And so if we write that together, oh, I forgot a negative. This should have been negative 15 here. So we'll make this a negative. So we have 3 negatives. This should really be a minus. Sorry about that. Because this is quadrant 3, both the x and the y are negative. So I got to have that negative right there, which makes this negative for the sine of beta. So these would pair up and give you a positive, but then it's being subtracted. So minus there. So if we put it together as a single fraction, 2 times the square root of 2 minus the square root of 15/12. So those are cases 2, 3, and 4, and then we just have one more case to look at.